Good morning, Calculus, and welcome to Chapter 6. This is application of derivatives. So we're going to use our derivatives to actually sketch graphs now and see what they do. So make sure you have 6 open to 1, and you'll probably need a calculator. So let's go. All right, so today we're only finding absolute extremas. And we're going to do this over an interval. Okay, the highest point or the lowest point on a given interval, in an interval can only have one, absolute extrema. It can have multiple relative extremas, but only one max. So now when we go here, and I want to go from 0 to x3. So we're going from here to here. And I want to find the max and the min, the absolute. So there are more than one when you look for relative maxes, but there's only one absolute max. So you go here before x1 and x3 would both be relative maxes, but the absolute max is the absolute highest, which would be x1. Min, now, if you did the entire graph, there would be no min because it goes down forever, but on our range, x2 is your absolute min. So it's just highest and lowest. Nothing too major. Okay, now when I look through, I want you to pause and actually do these. Find the max, find the min. And I already had them listed for you. That's too bad. So when we do points, you also have to include the endpoints. So that's a max. Min, the min endpoint is not a min this time because there's a lower one. This one here you can't see. It was just a straight line, which gave you the endpoints as your maxes and mins. The third one, sorry about the jump. Okay, the max was the highest. The min is the lowest because we had a thing. But remember, we do have relative mins in here, maxes and mins too, which we'll talk about later. Okay, open intervals that don't have max or mins are the ones that go on forever, or they have open circles. So like here, we have 2 asymptotes. So this means this goes on forever between A and B. It does have a min at x1, but there is no max because it will go on forever. There is no endpoint to check. Here, we have an absolute min right here. This guy's the lowest point because he's filled in, but we do not have a max because this here can get so close but never be exact, which means no matter what number I pick, so like let's say this here guy was 1, and you said, well, I'm going to pick 0.9. Well, then I'm going to say I'm going to pick 0.99, and we could do this forever, correct? Since there's no way to be exactly the top, it does not have a max. All right, so when you're checking for absolute mins over an interval, first you check the interval itself, open. You look for your critical points. Then you check your endpoints of the interval, and then you compare all of them to see who's the highest and the lowest. So let's go through here. In order to find this is done by the first derivative. So this is my equation, x 8 to the 8/3 minus 16 x to the 2/3. I'm going to check on the interval -1 to 8. Very important, don't forget. So we do our first derivative. We bring down the 8/3, subtract 1. Bring down the 2/3, subtract 1. All right, be careful here. Now remember, we always take out what they have in common. Well, 8/3 and 32/3 has 8/3 in common. When you look at your exponents, you always take out the lowest. The lowest one here is -1/3, so we factor it out. So now when you're thinking about this is x to the 5/3, and I'm factoring out, or I'm dividing by x to the -1/3. Remember, when you divide, you subtract exponents. So that's 5/3 minus a -1/3, which gives us 6/3, which equals to 2. And that's how we got the x squared here. All right, now I just rewrote it. I put the negative exponent in the bottom. Now we have to set this equal to 0. So this f prime equals 0 is what I'm looking for. That means we only set the numerator equal to 0. So x, because the denominator would be undefined, you'd be dividing by 0. So we solve this, and we get 2 and -2. But our interval was -1 to 8, so -2 does not count because he's not in my interval. All right, if I made my interval larger, he would be absolutely important. So now we've got my graph, and I've got 2, 0. I forgot to mention, this guy right here is your 0, right? So we've got 0, we have 2, and then we have our 2 endpoints, -1 and 8. So we have to plug in -1, 0, 2, and 8. And we just plug these back into the original function. So this is back into original. So when you plug it in, you get -15, 0, -19, 192. Well, the lowest is -19, so 2 is my absolute min. 8 is 192, so he is my absolute max. And this is what their graph looked like if you wanted to see. Do that on decimals, it really helps. All right, I want you to pause and try yours. Okay, I hope you did a good job. First derivative, you took the 2/3 down, you had to -1/3. 5/3 down, -5x to the 2/3. Factoring out what they had in common, which this time was x to the -1/3. You had 2 minus 5x because 2/3 minus 1/3 is 1, correct? Set them equal to 0. Well, this guy here is undefined. Since he's undefined, he's still a critical point. We don't know what he is, but he's bad. Okay, then you have 2 minus 5x, solve him, and we have 2/5 on the interval 0 to 8. So we have to check 0, which happens to be both of them, 2/5 and 8. Plug those into your calculator. You should have got 0.97, -84, making 0.97 your max and -84 your min. Hope you did a great job. These are kind of fun, don't you think? All right, now if we go from -infinity to infinity, sometimes we won't have absolute maxes and mins. We'll have relative maxes and mins, and sometimes we'll have absolute. So if we do a -x to the 4th, the first thing you need to do is remember what that looks like. So remember, it's a 4th root facing down because it's negative, so it looks something like that. I know my drawing's terrible. Okay, now we do our first derivative. By looking at this, we know there is no min. But I should have a max, either here or here, right? I have a relative min, but not an absolute min. So first derivative, -4x cubed minus 12x squared plus 16, taking out the -4x, factor this guy, and we've got 0, -4, and 1. Over infinity, so these are the only 3 points we're going to plug in. And we plug them in, and we get -4 is the highest, so he is my absolute max. This guy would be a relative min, and this here would be a relative max, depending on our interval. All right, pause and try yours. Okay, I hope you did a good job. So you should have done your first derivative. You should have realized it was like the w facing up, taking out the 12x, factor all of them, and our points are 0, 2, and -1. Plugging those into your table, your absolute. So this is your absolute min. Should have realized we do not have a max since it goes on forever, but this would be known as a relative max. And this guy is a relative min. But this is my absolute min. They're still all 3 turning points, which is very important. All right, I hope you did a good job. Make sure you post questions on the discussion board, and have a great time and good luck on your homework.